Hello, my name is James Wong, RF Product Marketing Manager at Linear Technology. I'm going to talk about how to extract the most performance from Linear Technology's LTC5599, a very low power, direct conversion IQ modulator. Such devices facilitate high order digital modulation to achieve a higher data throughput rate with minimum spectral bandwidth, thus allowing more efficient use of the frequency spectrum. The LTC5599 modulator comprises an on-chip polyphase filter which generates precise quadrature phase shift for driving the LO inputs of the I and Q mixers. Their outputs are then summed to form the composite RF output signal that is sideband and carrier suppressed. The LTC5599 modulator operates over a wide frequency range from 30 MHz to 1.3 GHz. At less than 100 milliwatts consumption, it is the lowest power modulator of its class in the market, with no trade-off in performance. The modulator typically exhibits sideband rejection of -51 dBc and carrier leakage of -53 dBm. These performance metrics are hard to beat and are sufficient for many applications, and they can be improved further should that be needed using the on-chip calibration facility. The 5599 also has excellent noise floor of -156 dBm per hertz with an output IP3 of +20 dBm. For the more demanding applications, the device has a set of registers that are accessed by an SPI serial bus. Through the SPI bus, you can select specific registers that tune the LO frequency, change the gain, tune the I and Q channel DC offsets that optimize carrier suppression, tune the I and Q gain and phase balance that optimize sideband suppression, and finally, provide temperature correction and operating mode functions. Note that all registers have default values, which are automatically set when the device powers up. In the default state, the modulator is fully operational, but may not be at its optimum performance level. To help us see what's going on, we have available this evaluation demo board setup, along with a companion serial interface board that connects to your PC. The first time you run quick eval with the LTC5599 connected and powered up, the PC will automatically download and install this graphical user interface software onto your PC. You can talk to any of the on-chip registers by typing the desired codes into the appropriate registers. Before we adjust the sideband and carrier suppression, you should first set the modulator to the intended operating frequency and set the gain. Let's suppose we want to transmit at 700 MHz, but when the chip powers on initially, its default frequency is 490 MHz. Obviously, the frequency is far off, and the sideband is suppressed -34 dBc. From the frequency table in this datasheet, we find the optimum frequency and enter that register value into the PC, or simply enter the LO frequency in megahertz, and the correct register value is loaded. We can see the sideband suppression improves to -65 dBc. Next, we set the digital gain register, which provides a coarse adjustment of voltage gain from 0 dB to -19 dB in 1 dB increments. The default value is -4 dB. That's probably okay for many applications, but you can adjust as needed. It is important to note that adjusting the gain affects the supply current. As shown in this plot, as the gain is reduced, the supply current also drops to about 8 milliamp at its minimum. So it is possible to reduce the power consumption, but it trades off the gain and correspondingly its output signal levels. Now we're ready to calibrate the sideband and carrier suppression. With direct conversion transmitters, both the undesired sideband and the carrier are either in band or very close in. So suppressing them is important to minimize signal corruption. To dial in the best sideband suppression, we first change the phase balance register. We adjust until the image is at the minimum. Next, we adjust the I and Q gain ratio register in similar fashion and find the minimum. These two registers are interactive, so you may need to check and readjust iteratively until the optimum suppression is reached. By doing so, we have improved the sideband suppression to about minus 66 dBc below the carrier. We can also improve the carrier suppression by adjusting the registers that provide DC offset adjustments in the I and Q channels. The procedure is similar to that used in adjusting the sideband. They are interactive, so you may need to go back and forth between the two registers until the carrier is at the minimum. In this setup, the carrier suppression can be adjusted to achieve below minus 70 dBm. In summary, you can see how flexible the LTC 5599 is in attaining unprecedented performance while providing the lowest power consumption of any IQ modulator in its class. For more information, please visit linear.com. Thanks for watching.